Hello, welcome back to my workshop. In this video we'll be looking at building my new 3D printed wedge case for the Mister Multisystem. So just some slicing details and then assembly of the 3D printed parts. So let's get on with it. Before we get going with the 3D printing and assembly, I need to thank a few people to help make this project possible. Neil Thomas over at RMC had the idea of the multisystem. I'm really glad that he did this. When I made my first case, I would have loved this. Having the back plane without the stack of boards, great idea. Richard at a company called HOWTO, who is actually his landlord in the new building, runs an electronics company. And they got together and they made this a reality. Early on, Neil contacted me saying how much he liked my old case and would I like a demo unit so that I could design some new ones for the multisystem. And of course I said yes, I would love to. So I was lucky enough to get one of the first 500 that went out. Thank you so much for sending this over. It's so hard to design a case without physically having the parts that go inside. Just because they go together in CAD doesn't mean that they all go together in real life. Next I need to thank Filament and Ravi. Ravi got in touch, saw some of my projects and said, would you like to work together? And he very nicely sent me over a care package, a nice collection of their materials, and also a couple of spools of their recycled PLA. I was really happy to use recycled PLA in this project. Working through some of these large prints uses a lot of material. At the moment, it's not really easy to recycle what I've got, so using recycled material is a great help. Filament is recycled and it comes on the cardboard spools. So Ravi gave me a discount voucher that you can all use, give you 10% off your orders. And that is also an affiliate link, so it does help me with the channel. All right, that's enough of the yakking. Let's have a closer look at the case. Here we are. This is my Multiwedge. Case is designed around this keyboard, which is a Newman GM610. I picked this one because it was relatively easy to find. It does come with two types of keycaps. We have this classic color, and also a red and blue. Here you will see a picture of the first case that I worked on, which is in red and blue. And that was using the EC-SSHD PLA that came on the refills. For this case, I did go with the recycled filament. And I chose these three colors that I thought went well with the keyboard. So like I said, we have a light gray. This trim is an off-white. And then the top is a moss gray. I really liked how it looks with the keyboard. I thought it was a good contrast. On the top we have three buttons, so the on-screen display, game reset and full reset. The keyboard does just sit in, so there's nothing holding it in. It just rests on, and there are alignment pegs that hold it in place. If we look on the side, this is the power switch, and we'll see later how I did that. There was also a vent on the side for the fan. On the back we have the I/O port. I'm using the original files that come with the multisystem case. So there are a few different options on here, and this one is the one that uses the SCART lead. And then on the other side, another vent, and this is a port for a joystick, and I'm using the Monster Joystick converter, so it will detect between a few different styles of Atari style joysticks or Sega. And I forced this one to detect a 6-button Sega controller. I have a fight stick that we can use with that. The design of the case was made to hide any joins. So all of these grooves hide the fact that the keyboard is made up from 3 parts. You really can't tell that it's made up from multiple parts. Same with the grill on the back. It hides that join in the middle. I wasn't too concerned about hiding the joins on the back. But if you look at it from the front, you really can't tell that it's a 3D printed case. And that's one of my favourite parts about the design. Next, we will quickly look at some of the details in the slicer that you need to follow to print this. Before we look at the slicing, I just wanted to say that these are some fairly advanced techniques that we will be doing in Cura and Prusa Slicer, like the paint-on supports, support blockers, and sacrificial layers. If you're not quite sure on any of those terms, I recommend you watch some of the videos that I've linked to in the description. If you're okay with them, let's get on with it. Alrighty, let's have a look at slicing in Prusa Slicer. So if we just open one of the base parts, you don't need to print in any quality, so you could get away with 0.3 draft. I did sacrificial layers on holes that are recessed. If we slice, if we just zoom in and go up, we can see these two holes here, sacrificial layer. So instead of trying to do supports or drawing the holes in air, it does that sacrificial layer and then does the holes over the top. So you will need to drill those out. If we get rid of that and go to the base front right. So the front right is the one that has the power switch. And you could do a support for this one only. You could paint them on. But I found that it prints okay without them. It does make a little bit of a mess and you will need to clean it up. So that's entirely up to you if you want to do supports or not. Let's look at a keyboard section. So the keyboards will come in at this angle. So we just pick the keyboard, choose the place on face, select the face, and it will now drop it down onto the print surface. The keyboard has to be printed at 0.2. And you could do 0.2 speed or quality, it's up to you. So if we slice this, the reason that we did the 0.2 is I did the top two layers to allow us to do that color change. So if we choose layer 81, click plus, it will now do the command to do a color change M600. One thing to note is if you're using Octoprint, doesn't particularly like doing those types of commands. So I would avoid using Octoprint if you're doing a layer change. If we look at the top, so again we need to flip this over, so we select our face that we want to put down and we need to paint on supports for this section. So we pick our object, paint on supports, and we just colour this part in. If we slice, we now just get supports on that front overhang. So we do that on the left and the right side. The last part to look at is keyboard right. So in the keyboard right, I did another sacrificial layer. So again, highlight the object, place it face down. So if we slice this, 0.2, so we can see as we go up, it will do the bridging for that sacrificial layer, but we need to put supports on for these two holes. So flip it over. It's hard to see in the green. Paint on supports. And then support enforcers only and enable bridging. So now it will support those edges where the holes are. And then we have our sacrificial layer. So we don't need to do too many supports. So that's the details if you're using Prusa Slicer. Let's just change this to a Prusa. Let's just change this to a Prusa Mini. And like I say, I think the keyboard middle is the biggest part. So lay that flat. So we can see that that will fit on. And top left. So it will fit on a Prusa Mini. Okay, that's Prusa Slicer. Now if we look at Cura, so I'm just going to choose my Ender 3. I'm sure that's pretty much what most people will be using. So everything is pretty much the same in here. We could do low quality 0.28. So we could do 0.28. And again, we can see that it's doing the sacrificial layers. So let's look at the ones that needed support again. Keyboard right. So let's lay that down flat. And I think it's just as easy just to turn supports on in Cura rather than trying to add the support blockers for this. So generate support, touching build plate. And make sure that we're at 0.2 for the keyboard. So it will fill that whole section in. If you want to take the time to do the support blockers, you're more than welcome. And then we have the overhangs on the top. So pick our object, lay it flat. And now we need to do support for that section only. So if we slice this, you'll see that it wants to do support on all the overhangs on the edge. You could leave it like that, but it will print without it. So if we go back to our model, support blocker, add our support blocker in, choose the support blocker, position it roughly in the middle, scale it, turn off uniform scaling, stretch it to be the full width, stretch it to be wide so that it's enough to cover that block. And then we need to do the full height. And the last part is we just need to move it. So it covers all of that section in the red. So there we see we have the same support on the front section, but not on anything else. One last thing, I forgot to do the color change. So back on our keyboard, 0.2 layer height, slice, and then we want to go from layer 81. We go to extensions, post-processing, modify G-code, add script, filament change, layer 81. So now we get this little notification that there is a layer change. And that will tell your printer if the firmware supports it and you're not using Octoprint to do a pause, get you to swap the filament, carry on, so that you could change the color on the top two layers. So hopefully that helps you understand just some of the small tweaks that you need to do in the slicer settings of Cura and Prusa Slicer. Let's have a look at putting this together now. Before I show you all the parts, let's just quickly look at how everything connects. And you'll see that there are recessors, and that is for these screws, these machine screws that go through. And then on the other side, there is a hole for a captive knot. So that just goes in there. The two parts go together and you screw them together. Some other parts use the brass inserts. As you can see, there's one there and there is one there. And that is just pressed in with a soldering iron. I use this one where the tip is very stubby, so it doesn't push too far into the plastic. So let's quickly do these two. So we just put it in and then we just push down, and try to push down as straight as you can. So now we've got those inserts in there. The base is made up of these four parts, and we can chop and change things around. So this one I made for the Monster joystick adapter, but I also did this one which has got a snack extension. So it's just like a USB 3 extension, which means that we can plug the snacks in. So it really depends what you want to use as a preference. I like the Monster joystick because you can use the same thing in all the cores. So I'm going to put it together with that. All these parts use the same method to connect together, which is the 20mm bolt and the captive knot. So you'll see that there is a place for the nut to go in. They just drop in. Our bolt goes through. And then I use a rounded head Allen key so that you could do it at an angle. And you'll see as you do that, it just pulls the nut in. This front section also has one on the underside at the front. Goes in exactly the same way. A quick look underneath and you'll see that there's quite large gaps. You don't need to put supports in there, it's okay. And these parts here where the screws are recessed, they will actually be, they will have like a sacrificial layer. So you will need to drill those out with a 3mm screw. But that again means that you can do these recessed screws without having to put supports in. If we do the back, and don't try to over tighten them because it can kind of make the thing warp a little bit. So that's our back part. Now we just need to join these two parts together. And as you might have noticed, that there are registration marks so that things can't get out of whack. I tried to make the 3D print design easy on the registration, so it does have a chamfer on the bottom. If you squish the first layer down, it does compensate for that. That is our bottom section together. It's fairly strong, but once we put the other parts on, it will help keep everything together. So on this, you've got to put in the brass inserts for the multi-system mount. So
1, 2, 3, 4.
2 brass inserts for the keyboard. And on this one, I have them for the power switch, but I've changed it so that you screw directly into the plastic on the printed files. I did it on this one because I'm obviously taking it apart all the time. I also did them on the fan mount, but again, I've changed them so that you're screwing into the plastic because you shouldn't be taking them in and out all the time. So once it screws in, it should stay in. And like I said, if you wanted to use the snack, you can just unscrew it and put that back on at a later date. So in the back, we have the I/O shield that you printed and you got from the official Multisystem depository on Prusa printers. So that just wants to go in. Don't put it in too tight. And then we have our Multisystem board, and I've already got the DE10 in there. I'm not going to go through how to put all that together we can look at the videos from Multisystem to see how that's done. But the DE10 just slots on the top, and then you have these cables that extend the ports to the backboard. And then you have the HDMI pass-through. So this obviously sits on those 4 holes. Like that, and that just slots into the rear panel. I'm then using some more of the pan heads to screw the multi-system into the board. I think these are 6mm. Okay, so that is the multi-system fixed in place. Next, we'll look at the power switch. So you will need to very carefully bend this polyfuse over so that everything fits. We have the switch mechanism that I printed. So you can see that prints that side down, and that prints that side down. And then I just connected them together with some solid core wire so that it's like a pivot. You'll see that there is a hole just there. We feed the switch in through there. When you print that out, again, print without support. It will be okay. You just need to do a little bit of cleanup, a tiny little bit of cleanup underneath there. Just make sure that the switch goes in okay and moves freely. So it will only go in one way because of how the power switch fits into there. So you just put that through the hole, and then this just fits over the switch like that. We then have a 25mm pan head which goes in through this hole, and again you might need to just clean that hole up, and then that goes through the switch and screws down. It is on an angle, so it won't go all the way. Okay, and then the last part, like I said, I've changed this now, so I have brass inserts, but you will screw directly into the plastic. And I've just got some little plastic washers. So don't over tighten, because it will stop the switch from moving. So there we can see my very basic switch mechanism, but it works. My next option is an old SSD. So I'm using a USB to SATA cable. Links in the description to all of the cables that I've used. And we have holes in the case for that, so that would just fit over there. And we use more of the M3. So you are going to have to hold it in place. And line up the holes on the bottom. And again, these holes will need drilling out because of the recess. There we go. This is the cable from the keyboard, and I've just cable tied everything together. And when we connect up the hard drive to the lower of the two USB, there isn't enough room to use the top for a full-size cable, and then the keyboard connector goes next to it, like that. Now I'm going to put in my Monster Joystick connector, and I have that on a right angle lead. So that just goes. I should have done that before, shouldn't I? So that just goes in there. And I used two very short 3mm self-tapping screws for this. Okay, and then this just goes over the middle part and into this port just here. So that's our optionals, that's our SATA hard drive connected up via USB, and I'm using the Monster joystick. Next we have the Noctua fan, and like I said, I've got threaded inserts because I kept taking this in and out. But you should just screw directly into the plastic. And then we connect that up to the 5-volt fan. So there are our basic internals of the case. The next part is the back. So we have two parts, 4 threaded inserts to screw everything down, captive nuts. This one's a little bit tricky because I didn't put backs for the nuts to sit properly. So now that the back goes on, if you are going to connect anything up, do it now. Let's plug in our SCART lead. And you do need to take the cover off the SCART lead. And I just put that in. Like that. So it just sits in. A tie wrap on there. Our top now goes on, and you'll see that there are holes here, so that sits in there, and you want to make sure that your back is in okay with the IO shield. I'm using these countersunk machine screws. You might need to just drill these out a bit. Flip it over, and then we have some more of the button head machine screws. I think these are also like 6mm. Okay, that is the back part on. So now we have the keyboard. So the keyboard is split into 3 sections. So just like everything else, 20mm bolt goes through, captive nut. So you will have to manually line this one up because there's no registration. So that is the keyboard together in the 3 parts, and you really can't tell that it's 3 sections. It's such a good idea. The last part for the keyboard is the 3 switches. And I wanted to do this without using a printed circuit board. So with just 3 switches, they are 12mm by 12mm by 7mm tack switches. So easy to find on eBay and Amazon. They just go in to the holes, and then this part goes over the top. So you just have to just align everything up. Doesn't have to be too precise. The little groove on that backing board will hold things in place. And then I have some very small self-tapping screws
that will cut their own threads into the plastic.
So there we go, there we have our 3 switches. Nice and simple. And I just put on DuPont connectors. Doesn't matter which way around anything goes. So the first job is to actually connect these up. So J11. J11 is the main reset. And then J14, which is like the in-game reset, and J12, which is the OSD. So OSD, game reset, main reset. Before you screw anything up, you want to make sure that the keyboard connector goes through there. And if you need to do anything on your SD card, do it now before we start to screw this last bit together. So on the top, where we put our inserts in, there's little holes on either side of the keyboard. Don't tighten these up too much, we just want to get things in place, just for alignment. And then on the bottom, we have 4 screws, which are 15 millimeters. So there we go. That is our assembled unit. Now that everything's on, it's actually quite sturdy. It doesn't really move about or twist. And then the last part is the Neumann keyboard. And you can see the places where the screws were originally in. So you'll just have to pop like some of the keys off to take those little screws out. And then all we need to do is connect in the USB lead. And then just feed that cable back inside. Line it up with those pegs and it will just sit there. So there we go. That is our assembled multi-wedge. Before I connect this up to the monitor, I just wanted to show that I have actually removed the SCART lead that I plugged in earlier. The reason that I did that is it will not work via SCART with the 1084S that I'm going to use. So I will be using the VGA out with a lead that will go from the VGA to the 1084S. So I have my lead, which I brought from eBay, and it's VGA port to the RGB port on the back of the 1084S. And this will work for the Mister or the Spectrum Next. And then to get audio, I'm just using jack to phono. So I'll flip that around and then we'll plug it in. For power, I've got this 5 volt 3 amp brick. Power, audio, video. All right, that's the multi-system connected up to the monitor, and although I didn't pick it intentionally, the colours of the multi-system and the monitor go so well together. Unfortunately, I wouldn't use this on a day-to-day basis. I much prefer to have a proper VGA screen so that everything is upscaled and it can handle the rotation of many of the arcade cores. Not all of them were happy on this, and you'd have to be twisting it around. So having a VGA screen or HDMI to cover all the cores is so much better. So I bought this cheap on eBay, specifically for use on the Mister, and then I brought the Monster Joystick adapter, and with the help of Monster Joystick, we set the firmware to only work with this rather than trying to auto detect, it was a lot nicer. Okay, let's switch the monitor on. And then using my switch mechanism, which I'm very proud of, we boot into the Mister. Another great thing about this monitor is the adjustments on the front. And as we can see, the joystick is already set up to work in there. Let's just quickly go into a core, so Commodore 64 core. When this keyboard first turns on, defaults with a set of keys, including these function keys, like the numpad is turned on. So when we're in the Commodore core, for example, these are not going to be doing the letters that we want. So it's good at the start that the cursor keys are working. But if we wish to use any of these keys, like K, J and H, K, J, H, they're not doing anything. So you do have to do function and control to change the mode. Now if we do K, J, H, we can see that we get the letters rather than the control functions. So a small limitation of this keyboard, but that's just because it's so compact. So there you have it. That is my multi-wedge for the Mister Multisystem. Really happy with how that turned out. I think the design is great. I love the way that it hides all the joins, and my colour choice really goes well with this 1084S monitor. Just like my old wedge, the files will be available on my 3Ding profile. It will be $5, which is just a small contribution really towards keeping the channel going and covering the costs of the filament that I used to develop this. It was quite a lot of filament on top of the samples that I got. The other way to get the files is to join my Patreon, which I think is £3 a month minimum. So anybody that is a Patreon will get access to the files, including the old wedge case files as well. There will be links in the description for all the cables that I used and the keyboard, which will be affiliate links in the UK to Amazon. Again, little things that just help towards keeping the channel going and paying for future projects. Thank you all so much for watching. I hope that you found this easy enough to follow. It does require some knowledge of 3D printing. It isn't really a beginner's project as far as some of the slicer things that I did, but not too difficult. And there will be links in the description to videos that go into more details on those slicer techniques than I want to cover in this video. So again, thank you to Neil and Richard for the multi-system and Ravi for the filament samples and the first few spools. I did buy more spools myself afterwards. I quickly got through those first few spools doing the testing. It's great filament. I've enjoyed printing with it. So again, thank you all for watching, and I'll see you on the next one.